at how to calculate pressure at the base of a fluid. So pressure calculation. And basically there's one formula, which again you get given on the formula sheet if you need it. There's one big formula, P equals rho GH is the formula that you need. For all of your pressure calculations, that's basically it. And this tells you what the pressure at the base of a fluid is, or below a certain height of fluid. So P is pressure. Units for pressure. Any takers for the units for pressure? Not quite. Newtons per metre squared. Okay, true, but there's another name for that as well. We have a pascals. Okay, so pressure is going to be in pascals. Density we've already just met just before. So density is in kilograms per cubic metre. G is just the old 9.81 metres per second squared, acceleration. And H is what we call the head of pressure. And that's just going to be in metres. Okay, so we're just going to say a certain height, a certain head of fluid is going to produce a pressure at the base of that head. So if you've got a pipe coming from a reservoir, so you've got a reservoir up on the top of a hill somewhere, that's a reservoir. Hills, of course, are green, so that's a hill. And you've got a pipe running off that reservoir, and the question is going to be, what pressure is the water going to have at the bottom of the pipe? Okay, so let's say this hill is 75 metres up. It's got a 75 metre fall, or 75 metre head, is the phrase you'll hear used. Question is, what pressure is that fluid going to be at the bottom of the pipe? And we just use this formula. Tells us that the pressure is density times G times the head. So we need to know what the substance is. So I did say, yeah, so let's pretend our pond's got water in it. Fresh water, specifically fresh water. It would be slightly different, it would be 1,040 instead of 1,000. Okay, so it's only 1,000 for fresh water, times G at 9.81, times the head, which is 75, and Scott's got the calculator out. Yep, whack some buttons for us. $735,750 Pascal. So let's call that about 736 kilopascals. Yep. Okay, so 75 metre head will produce 736 kilopascals of pressure at the base. I guess a question of, is that very much, springs to mind. Is 736 kilopascals a high pressure or a low pressure, and what does it relate to? And the thing that we have to relate things to, or one thing, is atmospheric pressure. And atmospheric pressure is pretty close to 101 kilopascals. 101.3 is standard, which you'll also see 101, chuck the 3 on it, hectopascals. And the reason I'm giving you that one is next time you watch the news and you see Jim doing the weather at the end of the news, you'll see the numbers that look a lot like that all the time. Yeah? So that's your standard atmospheric pressure. And no, I mean, it depends on what, it'll be different pressures at different temperatures. So on different days, you can have a high pressure day with high or low temperatures. So it's not just the temperatures definitely affect factor, but it's not the only factor. So you'll see sometimes it'll go down to a 995 or something, and it's a really low pressure system, or up to maybe as high as about 1035, 1040. It's a really high pressure system. So atmospheric pressure is about roughly 100 kilopascals. So this is 7 atmospheres of pressure is what's going on there. Okay. Here's an interesting question, using the same idea, which is, what is atmospheric pressure expressed as a head of something? So, type of question you might see, what is atmospheric pressure expressed as a head of, say, water? So the question that's really asking is, if you had a tank full of water and you put a tube in it, yep, and you sealed, it was a sealed tube, and it had a vacuum in it, so there's no pressure inside it, then the atmospheric pressure is going to be pushing down here. And what will happen is it'll cause the water to get pushed up the tube. And the water will get pushed up the tube until the pressure here, the pressure of the water, is exactly equal to the atmospheric pressure. And then it'll be balanced out, because what's trying to push it up the tube will be exactly equal to what's pushing it down the tube. Yep? And we can work out what that height is. So this is atmospheric pressure, the same amount, expressed as a head or a height of, in this case, water. So we can just do our calculation. So we can go P is rho GH. We're trying to find the head in this case. Bit of algebra. So the pressure is 101,000 kilopascals divided by density. Oops, density is not 9.81, that's G. Density is 1,000 times 9.81. Gives us, so I'm going to push, yeah, 101.3 kilopascals, so 101 pascals. So I've put everything in pascals, kilograms per cubic metre, standard number. So I've put everything in basic SI units. I could have just put it in pascals, so I left it in kilopascals, and then my answer would have come out in kilometres. So the answer now should come out in metres. And the answer is 10.3. Yep. So what that means is, it doesn't matter how good you are, even if you're a perfect sucker, you can never suck up water up more than 10 metres in a straw. So you have a straw, if you're trying to drink your beer on the second floor story of your flat with a long straw, as we've seen people attempt to do before, if you're more than 10 metres above the ground, it doesn't matter if you put your vacuum cleaner on, you're not going to be able to suck your beer up. It's not going to happen, okay? Even if it's got a perfect vacuum in here, you're not going to get more than 10 metres of water up a tube. It's just not going to happen. Okay?
Oh, so that's what we should do if we stop people from drinking beer, is put them 10 metres.
Make them have straws that are more than 10 metres. That would solve all of Dunedin's binge drinking problems. If you passed a law that you're only allowed to drink beer through straws of more than 10 metres, you'd be safe. Yep, yeah, exactly. Yep. So this is what we mean by atmospheric pressure as a head of a particular fluid.